In this video, we are looking at worked problem 15 on page 720 in the John Bird textbook, Understanding Engineering Mathematics. Okay, so we are given this integral and we have to evaluate this integral. So for this particular integral, we will have to use a trigonometric substitution. And the substitution that we're going to use is the sine theta substitution. So what we basically do is this: we let x be equal to a sine theta. That is the substitution that we make for this one. Of course, we are going to have to differentiate x, so we have to find the derivative of x with respect to theta. Okay, so we go ahead and we differentiate. Now, differentiating a sine theta with respect to theta, we are going to have the following. The a is a constant, so you're going to take the a out of the derivative, and you're going to differentiate sine theta. The derivative of sine theta is cos theta, so this is going to be cos theta here. So dx d theta is equal to a cos theta. Now, we can write this as follows. We can write it as dx is equal to a cos theta multiplied by d theta. So we can write it in this form. So now we have to substitute this into our given integral. So we say, therefore, the integral of the square root of a squared minus x squared, the integral of the square root of a squared minus x squared with respect to x is equal to the integral of the square root of a squared minus, now we substitute our a sine theta, square that. So that's what we have now under the square root sign. In place of dx, we put a cos theta d theta. A cos theta d theta. That's what we have now. So this is equal to the following. So now this is equal to the integral of the square root of a squared minus a squared multiplied by sine squared theta. So this is the same thing as that. And we still have that a cos theta d theta over there. So now we can factor out this a squared. This a squared here, we can factor it out because it's a common factor over there. So now we have the integral of the square root. So now we factor out the a squared. And inside the bracket, we've got 1 minus sine squared theta. Close the bracket. That is all under the square root sign. And we still have that a over here, cos theta d theta over here. Now this thing over here is the same as cos squared theta because of the unit circle trigonometric identity, okay, which states that sine, okay, let me write this again, which states that sine squared theta plus cos squared theta is equal to 1. So if we solve for cos squared theta over here, we will get 1 minus sine squared theta. So therefore, that means that we can replace 1 minus sine squared theta with cos squared theta. So let's go ahead and do that. Let's substitute. So now this is equal to the following. This is equal to the integral of the square root of a squared multiplied by cos squared theta multiplied by a cos theta. This is cos here with respect to theta. So now, obviously the square root sign is going to cancel out the squares there. And now we are left with the integral of a multiplied by cos theta multiplied by a multiplied by cos theta with respect to theta. So this basically equals to the following. The integral of a squared multiplied by cos squared theta with respect to theta. So now we can finally take out the a squared because it is a constant with respect to the integral. So we can take it out of the integral. So now we have a squared outside multiplied by the integral of cos squared theta with respect to theta. Okay. Now, what can we do about the cos squared theta? If you look in the formula sheet, you will see that we can write the cos squared theta is in the following way. We can write cos squared theta as 1 over 2 multiplied by 1 plus cos 2 theta. So we can write cos squared theta as a half times 1 plus cos 2 theta, right? We can use this identity here, which is given in the formula sheet. You find this in the formula sheet. So use that, go ahead and we substitute into our integral, and we get the following, okay? So let's remove this now. We take that identity, we substitute it into our integral. Now we have this, we have a squared multiplied by the integral of half plus half multiplied by cos of 2 theta. Okay, we put that in brackets, integrate that with respect to theta. So this is the same as the following. We've got a squared multiplied, so I'm going to put a square bracket here, multiplied by the integral of a half with respect to theta plus the integral of a half times cos 2 theta. So we can place the half outside because it's a constant, multiplied by the integral of cos 2 theta with respect to theta, close bracket. So now we go ahead and we integrate each of these terms, okay? So we've got a squared outside, square bracket. The integral of half with respect to theta is obviously a half multiplied by theta plus half outside here. And the integral of cos 2 theta, you can look in the formula sheet again to evaluate this, find the formula that corresponds to this integral, and it gives us the following. Okay, so by looking at the formula sheet, we get that the integral of this cos of 2 theta with respect to theta is 1 over 2 multiplied by sine of 2 theta. Okay, we close the bracket and we don't put the plus c yet. Okay, so we go ahead and we simplify this. We can multiply the a squared inside the bracket now. So we've got a squared over 2 multiplied by theta, okay, plus a squared over 4 multiplied by sine 2 theta. Okay, so this is what the integral evaluates to. Okay, it becomes this. But remember, we have to leave the answer. We have to leave the answer in terms of x. Okay, because the problem was presented to us in terms of x over here. So we have to leave the answer also in terms of x. Okay, now let's go back to where we are. Now we're here. So we have to write theta in terms of x. Over here, we're going to write theta in terms of x. And we're also going to write sine 2 theta over here in terms of x as well. But first, before we write sine 2 theta in terms of x, we are going to rewrite sine 2 theta using a trigonometric identity. If you look in the formula sheet, you're going to see that you've got the following identity. You've got sine 2 theta is equal to 2 sine theta multiplied by cos theta. So this is found in the formula sheet. So look in the formula sheet, you will see this identity. So you use this identity to replace sine 2 theta. Okay, so let's go ahead and do that. Let's use this identity here to replace sine 2 theta. And then after that, we will then replace theta and write it in terms of x. So we have a squared over 2 multiplied by theta plus a squared over 4 multiplied by, so now we replace sine 2 theta with the identity, which is 2 sine theta multiplied by cos theta. And then now we can see that over here we can cancel out the 2 and the 4. Okay, so the 2 cancels out with the 4, and that gives us the following. Okay, in the first term we still have that a squared over 2 multiplied by theta plus, so now we've got a squared. In the second term we have a squared over 2, okay, multiplied by sine theta multiplied by cos theta. So that's what we have. So now we can then go ahead and replace theta in terms of x, write theta in terms of x. Let's go ahead and do that. So to do this, we go back to our substitution. Now in our substitution here, we said x is equal to a sine theta over here. We said that x is equal to a sine theta. So we use that to write theta in terms of x. Okay. So let's go ahead and do that. Okay. Let's go ahead and do that. So we say, okay, let me rewrite that. We said the following. So x is equal to a sine theta. Now this implies that x divided by a, so we divide both sides by a, you get x divided by a is equal to sine theta. You get that. So if you continue with a and you apply the inverse sine function on both sides of that expression, you will get that theta is equal to sine inverse of x over a. Okay, so now theta is equal to sine inverse of x over a. So you can replace theta with sine inverse x over a. But then we also have this. We also have sine theta, and we also have cos theta. We want to write those also in terms of x. Okay, so let's go ahead and do that. Now, if you look at sine theta, we already have it in terms of x. Okay, sine theta over here, we've showed that sine theta is equal to x over a. So we're going to replace sine theta with x over a. But what about cos theta? What about cos theta? How do we write cos theta in terms of x? Okay, we can use the unit circle identity, which of course says that sine square theta plus cos square theta is equal to 1. Okay, so solve this. You solve for cos squared theta, you'll get that cos squared theta is equal to 1 minus sine squared theta. And we've used this identity before. We're just using it again. And of course, if you square root both sides, you'll find that cos theta is equal to the square root of 1 minus sine squared theta. Okay. So now we've written cos theta in terms of sine theta. So all we have to do now to write cos theta in terms of x is we replace sine theta with x over a. All right. So this over here is equal to the square root of 1 minus, in place of sine theta, we put x over a. And that's going to be squared. Okay. All right. And you can rewrite this. We can rewrite it. And when we rewrite it, we find that this is the same thing as follows. It's the same thing as a squared minus x squared, okay, over a squared square rooted. And you may write this as follows. Okay, you can write it as the square root of a squared minus x squared divided by the square root of a squared, which is just a. So that's basically what cos theta is in terms of x. Okay, that's what it is in terms of x. So if you go here, we're going to replace cos theta over here with that result, and then we're going to replace sine theta with this x over a, because sine theta is equal to that. So this is equal to, we still have a squared over 2. In place of theta, we're going to put sine inverse of x over a. Okay. Plus, got a squared over 2. In place of sine theta again, in place of sine theta, we are going to put x over a. We've shown that sine theta is equal to x over a. And then in place of cos theta, we're going to put the following. We're going to put the square root of a squared minus x squared divided by a, because we've showed that cos theta is equal to that in terms of x. So then that's basically what we get. Then we can go ahead and simplify this. So when we simplify this, the first term, it stays the same. It's a squared over 2 multiplied by the sine inverse of x over a plus, now over here, the a's at the bottom multiply, they give you a squared, and they cancel out with this a at the top. So you can see clearly that this a at the top here cancels out with this a squared at the bottom. Okay, so now we get the following. We get that this is now x over 2 multiplied by the square root of a squared minus x squared. So that's basically the answer written in terms of x. Okay, so the conclusion then is, therefore, the integral of the square root of a squared minus x squared with respect to x is equal to a squared over 2 multiplied by the inverse sine function of x over a plus x over 2 multiplied by the square root of a squared. Let me just write that again. The square root of a squared minus x squared plus arbitrary constant c, because it is an indefinite integral. Okay, so that basically proves that formula.